Hello, class. This is Professor Munshi, and we are in ITSY 1400 Fundamentals of Information Security. Today, I am going to present to you Module 13 from our courseware, and that is Incident Preparation, Response, and Investigation. Module 13. So, let's get started. And the first thing we're going to discuss is the reasons for cybersecurity incidents. Let me explain to you what a cybersecurity incident as opposed to an event. There are so many tools that we use to record, monitor all the events that happens. Okay, events means like somebody opened a file, somebody logged in, logged out, somebody deleted a file, somebody accessed a server. Everything is an event. Any little thing that happens, that is an event. Okay, with the including the cyber security, um, including any event, anything that happens that relates to security is an event. As opposed to an incident is when a something like our integrity or confidentiality or availability is compromised. So typically, an incident is bigger than an event. An incident typically is made of one or more events. Okay, so every event is not necessarily an incident, but every incident will have one or more events, if that makes sense to you. So we're talking about here an incident, meaning a big thing happened that compromised cybersecurity in some way. Okay, so we are talking about the reasons for it. So there are two types of basic broad two categories. One is the weak account types. Okay, if we have some vulnerable types of accounts, user accounts that can access the system, then we are more vulnerable, and we cyber incidents could take place because of those weak accounts. What are the weak accounts? The three of them, for example, uh, the first thing I would say is a weak account that has very weak authentication or no authentication at all. A user account without a password, for example, or with a very weak password, that's definitely a weak account. Okay, so any account that can be easily breached, that's a weak account. Also, there are certain types of account, they are more vulnerable by their very nature. For example, here we are discussing shared account, generic account, and guest account. What is a shared account? An account that is shared by many people. So you don't have this non-repudiation there. Who accessed that file? Who deleted that file? Who did this event? You may not be able to identify, or somebody could deny that. Somebody could say, I didn't do it because 10 of us are using the same account. It's a shared account. A generic account is very similar to that. For example, you have a user account, you say for your department, like say one account is called HR, that's the name, human resource, or an user account is just named as user. And many people, you are allowing many people to use that account. Okay, that's called a generic account. Like a generic mail account would be, for example, that you say info@yourcompany.org, and or you can say admin at yourcompany.com. So that account you is just coming to admin. It's not somebody's name, and you could have several people who is accessing that admin account and check the email. For an example, a guest account is another account, very vulnerable. That is by default is there already available in the Windows operating system, for example. Okay, it is always good to disable the guest account. Okay, next, we're talking about weak account types. Okay, also another reason for cybersecurity incidents is poor access control. Access control, access control, comprises from A to Z, from someone, from a user, identifying himself as a user, authenticating the user himself as he is the right person, and then accessing the resources and then performing with that resource whatever he wants to perform. The whole thing is controlled by access control. Okay. Now let's talk about a little bit about there are standard access control models that are used to help enforce access control. In the industry, there are several very well known methodology of how to implement access control. There are some principles. Let's talk about them. The five of them. Okay. Now, here before we we're talking about those five different access control, like role based and rule based and attribute based and mandatory and discretionary. Before we talk about them, let's talk about, I see that in this slide talking about some concepts. Identification. Let's know what identification is. Identification meaning a user name. For an example, somebody is saying I am John Davis. That is identification, because this account is for John Davis, for no one else. So a person comes and he says, I'm John Davis, identified as such. That is the first step. Look at the second step. Here is authentication. Authentication means now you're going to verify that, okay, you are saying you are John Davis. How do I know that? Do you have your ID card on you, with your picture, so I can verify, I can authenticate that it's you? Do you have your password? Do you have your access card that you can scan to come in? For the computer, to log into a computer, it will be a password, of course, some kind of challenge that you are going to throw at him. So he needs to prove that, he needs to authenticate that he is indeed John Davis, whether he knows the password. Okay. Or you could do a biometric scan of him, or any way you can authenticate. That's called authentication. Okay. Now, authorization. After that person is authenticated that, okay, yes, he is John Davis. Now you are going to grant him, your computer is going to grant him an access token. That, okay, here is your token. With this token, you can only access such and such place. You can only access those files, those folders, those programs you can execute. However, you cannot access this other folder that is very confidential. Only management can access that. So each user is going to have some kind of authorization token. Okay. Now access. Another term here is access. Access means the right that is given to him, the token. That is the access. Okay. You are authorized with that access. Accounting is keeping a log, keeping a record of what you do. You, as many files you open, you launched a program, you closed the program, you entered some data, you modified a file. All those things is all those things are recorded, okay, in the log, system log, application log, and all kind of logs. This is called accounting. So later on, you won't be able to deny that it was you, or your account has done those actions. Next. Now, also need to learn some more terminologies. Object, subject, and operation. It's important to learn that an object is actually a resource, like a file, a folder, a printer, and a website. Anything that you access, anything that you use, any resource that as a user you use, that resource is called an object. And here you, or the user, is the subject. Okay, subject is the one that is a human, for example. Sometimes an application, sometimes a program needs to access some data. In that case, that data is the object, and this program could be the subject, because this program is now given privilege to access that data. So subject and object we got. Operation is the action performed by the subject. Like you launched a program. So what you have done, the program was the object, you are the subject, and the action was launching the program, as opposed to, say, uninstalling the program, installing a new program, okay, deleting a file, modifying a file. Those are actions or operations. Next, move on. Okay. Now here are different types of access control. There are different types of access control schemes, and this is something we really need to learn, we really need to understand very well, because in the exams you actually would expect that these concepts are very much asked of you, tested. The first one we're talking about is discretionary access control, DAC. Second one, mandatory access control, MAC. Role-based access control, RBAC. Rule-based access control, and then you have attribute-based access control, ABAC. So let's discuss one at a time. Discretionary access control is a type of access control, a type of security that you implement uh, in which every object has a owner. Okay? Every object has a owner, and the owner at his discretion decides who else can access the object. Owner typically has a full control over that object, but the owner can say that such and such user, I'm opening that up to every user. So every person is able to access. Every person is going to only have read access as opposed to full control. Like they couldn't delete it, but they could read it. You could set that access, that kind of access. Okay. So, so basically, the owner gives permission to whoever he pleases. That's called discretionary access control. How do we remember it? Just remember, at the owner's discretion. Okay. In the Windows operating system, you can do that. Like you create a file, you can change its access control. You can, you can give access to everyone or certain groups or certain users. Yes, you can. It has two significant weaknesses. One is that it poses a risk because all the decisions are made by the owner, and there could be errors by doing, and it's rather clumsy that you are always at your discretion, keep on assigning access. Then also, a subject's or a user's permission is inherited by any program that the subject executes, meaning whatever program you are executing, that program will carry the access rights that are given to you. Okay, anything. So that too is a dangerous thing, that a program could get more access than it should because of the discretionary setup. Let's talk about the next one, mandatory access control. It is exactly the opposite, the most restrictive access control. In here, every object, every resource has a label. Okay, meaning how, what kind of security it should have. You could have like this, public, then private, then secret, top secret, like that, some different category. So every object has a label on it, and every subject has a label also. Okay, so every user has a label also. So those labels has to match. So every time a user is trying to access an object, that object's label and its will be compared with this user's label. If the user is just a common user, not an admin, not a manager, okay, it only this user only has a standard user access label, and this data, the object has a top secret label on it, this user will not be able to access that folder or that file, because that data requires higher level of access rights. So this is very, very restrictive, and like in the military they use that MAC, mandatory access control. Okay, so MAC grants permissions by matching the object labels and with the subject labels. Just remember that. And of course, it always will do the least amount of privilege it will grant. Okay, least amount of privilege it's going to grant. Now, next is role-based access control. This is very well used in most of the companies. Like instead of assigning access rights to each user, what you do is this. That's a lot of work, because every user you have to grant one by one access rights. That, okay, this user can access that printer, and he can access that folder, but he cannot access that drive. Well, it's so difficult to do that, so clumsy to manage every user like that. So what you do, you create some groups based on roles. Like one of the names of the group would be manager. Another is like administrators or admins group. Another one may be, say, accountants group, students group, faculty group. So you create groups and you assign access rights, appropriate access rights to those groups. And then you could just add any user to the groups that he should belong. Okay, for example, management, they should have certain access. So you create a group called management and assign all the appropriate access to that management group. Now, if a person becomes a part of the management group, all you have to do is just add that person, add that user to that group. And if that person leaves, no longer in the management group, just remove him from that group. That's it. That's called role-based access control. Very nice, very well done. Okay. So this one is based on a user's job function. Next, rule-based access control. Okay. That's called RBAC. Okay. Like rule-based, role-based access control. So this one is similar to role-based, but the roles are now set by some defined rules. Okay. Certain rules are set. Based on those rules, you create the roles. That's the only difference. Okay. So like it says here, each resource object contains access properties based on rules. When a user attempts access, the system checks the object's rules to determine access permission. So every object has some rules that you set to it. Okay? And then based on what role this user has, that role will be compared with the rules of that object. That's pretty much rule based. Okay. And the last one is attribute based access control. That is a very interesting one. A user, any subject, or any object, any resource can have its attributes. For example, you can have a user an attribute that he's a new person. Say 90 days later, he's going to be a standard person. Okay. Or say another user comes from a foreign country, and you categorized him as a foreign, uh, you know uh, you put an attribute on him as a foreign. You could even have attributes like day and night, that some object you want the users only to access in the, say, AM hours, not in the PM hours, okay, per se. So based on environment, time, place, you can have attributes assigned to objects and subjects. Very interesting. And then based on those attributes, you can grant the access rights. Okay. For example, it says right here, these ABAC rules, or these access attribute based access control rules, can be formatted using if then else structure. What does that mean? Meaning, say you are talking about, you want people to be able to access this folder only at in the PM hours. Then you can set this rule like this: if PM hours, then grant access, else don't grant the access. Like that kind of rule you can set. Okay, based on the attributes. Okay, next. Now we're still talking about reasons for cybersecurity incidents. Okay, now learning a few things. What about access control list? Okay, access control list is a set of permission attached to an object. You have a list, like for example, in the firewall, you have an access control list. In Cisco router, you have an access control list. Same way, an object, a file or a folder, any resource can have its access control list. And basically it's like a filter. It's going to say that only allow so and so from the, uh, if the source is such and such IP address, allow it. Or if the source is such and such user, allow it. Everybody else is denied. That's called an access control list. Okay. Access control list provides file system permissions for protecting files managed by the operating system. This is an example. Next. Okay. Okay, move on. Okay. Now we're talking about preparation for an incident. Okay, an incident again is something that has compromised cybersecurity. That's an incident. Okay, significant enough to be to affect cybersecurity. Now, always the companies, they should create an incident response plan. That is extremely important. And also an incident response process prior to incidents takes place. That's why we're talking about the preparation. How do we prepare for an incident? Of course, beforehand. The incident response plan, that there you're going to actually write the instructions exactly what to do when an incident happens, who is going to be the first responder, what protocol they should follow, who they should notify, what steps they should take. That's a thorough plan would be there, and a process that will be step by step process also would be followed. Okay, now let's talk about the 6 action steps that are part of the process. That we're talking about the preparation. That is the first one. Preparation has all inclusive, meaning creating a plan, creating a cybersecurity incident response team. That's called CSIRT, creating a team so that they can be the first responders and handlers of the incident, bringing all the tools, resources, hardware and software necessary to do your incident response, collecting everything. That's part of the preparation. Then you are going to have identification. How do we identify whether it's really an incident? Could be just a suspicious activity, but not really an incident. And if it is an incident, you want to identify what type of incident it is and how much damage it may cause. That's called identification. Containment, meaning once you have identified this is an incident, you want to contain it, meaning you want it to stop from spreading further. Okay, you want to isolate it. And then eradication, that means you are killing it, you are removing it from the system. If it's a virus, you kill the virus, you remove the virus, kill the worm, remove the worm from your system. Recovery, you bring back your normal operation into place again. That's recovery. Virus has been removed, now you're back into full operation, everything has been restored. That's called recovery. And then lesson learned, you're going to, after the incident is done, everything's recovered, everything's done, then you're going to ponder on it, that what have we learned, what should we do to our antivirus system. Perhaps we need to upgrade it, perhaps we need to change some firewall rules in the future. You take action. That's called lesson learned. Okay, let's go over them a little bit. Now, preparing. Okay, documented incident. Okay, now with an IRP, incident response plan, you should have these following elements. One is the documented incident definition. How do we define an incident? Certain trivial events may not qualify to be an incident. Okay, you may not want to spend your hours and time. This is not a significant incident. This even does not qualify to be an incident. So every company has to do make their threshold. Now, incident response team, as I mentioned, that is called CSIRT, Cybersecurity Incident Response Team. Very important. You have many members. There are some core members in the team whose primary job will be incident response. They will be monitoring the network, monitoring the systems all the time, monitoring the logs all the time, to know whether any incidents is taking place anytime, if there is any suspicious activity. Okay, and if there is, they are going to follow the protocol to investigate whether it's an incident. If it's an incident, they're going to take the right action. That is the team. Okay, core team. And then Some other people who have certain specialty or expertise, they may not be part of the core team, but they may be needed based on the incident type. If it is like a virus, then you may want to bring somebody who specializes on that. If it is a network DDoS attack, you might want to get your networking expert involved in it. So they are not part of the core team, but they will be brought in by the core team if necessary. Then reporting requirements and escalation. In the plan, you should have that. When do we report that this is an incident? There should be requirements. Sometimes you need to report to the law enforcement. Sometimes you need to report to even to your customers or consumers who have been affected. So there are rules and regulations, there are laws and standards regarding this process. That when and how, what are the requirements for reporting to the right party, reporting to the management, reporting to the law enforcement, external parties, and so on. Now, a retention policy. How long the evidence or all the evidence, all the materials related to this incident that had happened, how long your company should keep those evidence. Okay, so that is retention policy. Stakeholder management. Again, stakeholders are your management, your IT department, your users, your customers, your vendors, whoever is involved in it, whoever has been affected by the incidents, they are stakeholders. Okay, you need to manage them, you need to know how to notify them, what to do regarding them, what you owe them. And communication plan. How do you communicate internally within the company and externally with the external stakeholders? Okay, all of those things should be part of your plan. Next, preparing for an incident. Okay, we're talking about some examples of plans. Move on. Okay, preparing for an incident. Now, studying attack frameworks. When you are preparing for an incident, it is good to know some exploitation or attack frameworks, okay, so that you will know how attackers work. What are the steps the attackers follow to launch an attack? Knowing that, knowing their mindset, knowing the attackers or hackers methodology, that's going to help you be more prepared about an incident. Okay, and some frameworks that are available about how attack takes place, how hackers launch an attack. This mitre, ATT, and CK, this one model. Another model is the diamond model of intrusion analysis. Cyber kill chain. These are different models. Models of what? Again, models of hackers launching an attack. Let me see if I can show you an example. Cyber kill chain, for example, if I search by it. Okay, it's a very well known, okay, how attack is launched. Okay, it consists, look at this, the term kill chain is adopted from the military, which uses the term related to the structure of an attack. Okay, so cyber kill chain, right here I will be able to probably show you the steps that are involved in launching an attack. Let me come show here. Okay, cyber kill chain. Okay, perhaps internet is being slow. Okay, okay, look at that. This is the kill chain. Interesting. I came to the right place, looks like. Okay, first of all, they are going to do reconnaissance. They are going to investigate. So what I'm talking about, how attackers launch an attack. Okay, reconnaissance. They are going to learn about your company, about your IP address, email address, about your server machines, about your network topology, network diagram, your firewall. They're going to learn as much as they can. That's called reconnaissance. Step number 2, weaponization. Okay, they are going to create a, some kind of um, virus per se, malware. They create a malware, they create a weapon to launch, to send to you. They have not sent yet, They just created, after knowing you about your company, they created a malware, an attack mechanism for you. Number three would be delivery. Now they are going to send that to your company. Okay, it could be like a phishing attack. They're going to send a link to a bad website, like very vulnerable, very threatening, malicious website link by email. That's how they delivered. Maybe they delivered a malware in disguise of a benign software. Okay, that's called delivery. Number four, exploitation. Now that it has been delivered to your machine, one of your users has clicked on it. Okay, and now they actually exploited your vulnerability. Now that malware is in action. Okay, so then installation. So now they are able to install the malware. The malware has been opened up. Now it has been installed in your system. Number six, command and control. Now that malware is already installed in your machine. Now the hacker can remotely use that malware to control your system. Interesting. To do more things, okay? To exfiltrate data, to be able to log in, escalate the privilege, and perform many, many actions. Okay, so they are able to command your system to act certain way remotely. So they have possessed your system. Your system has become a zombie now. Okay, and the last is the actions on the object, the actual exploitation of data, actual transferring of money, deleting file, or corrupting the file, or stealing your data. Okay, these 7 steps. This is just one methodology. Okay, for example, I'll just give you an example that how, what are the steps hackers follow to launch an attack. Okay, next. So knowing, okay, now let's look at this knowledge check activity one. Okay, in which type of access control can access policies be based on the properties of objects, subjects, and the environment? Properties, okay, attributes basically, and can be constructed using if then else statement. So that looks like to me an attribute, that if this person is a new user, then access, let him access to this place. Well, it should be this should be the other way normally. If this person is 1 year old employee at least, then you allow the access, and if he's less than 1 year old, meaning else, deny access. This should be attribute based. So that should be number C. Okay. Next. Now, incident response. Taking advantage of this SOAR, runbook, and playbook. Okay. This is basically an automated responding system. Okay. This is an automation in response. It's very interesting. So, and what you do, steps that should be taken when responding to an incident, that includes the SOAR, runbook, and playbook. You want to know what is a runbook, what is a playbook. Okay, let me show you. A playbook, first of all, the SOAR, it is security orchestration, automation, and response. Okay, these are automated softwares, because sometimes in the enterprise level, to respond to every incident could be a huge task, and some of the incidents could be minor enough, some of the incidents can be straightforward enough that an automatic software can on your behalf actually respond to the incidents. Okay, so that kind of product, that kind of software exists, that you configure it, that okay, if this kind of symptom happens, then you do this. If you see an overwhelming DNS query is going on, perhaps we are getting an attack against our DNS server, then you take this step, you set up that way, configure that way to act automatically. Okay, that is the SOAR product. A playbook is a checklist that you can manually follow. Okay, when an incident happens, you want to follow the playbook. If you are manually making the decision, it says step number one, make sure that the crime scene is given. For an example, we're talking about, say, digital forensic. After the incident happens, that crime scene is secured. Okay, then say number two, all the evidence is preserved. Okay, Number three, say say contact the law enforcement or create a chain of custody. Things like that, step by step procedure. That's called a playbook. A run book is the same thing, but it's not being done manually, humanly. It is being now done by an automated software. Okay, same thing, same kind of things. So like next. Okay, now we're talking about, so what did we do here so far? Okay, now we're talking about perform containment. Okay, so incident response, in that process, containment is very important. Once you have identified that yes, indeed, an incident has taken place or right now is taking place, then you want to contain it immediately. You want to isolate the affected systems, the affected processes, affected segment of the network, whatever it is. You want to isolate that so it can no longer spread further to other systems, to other segments of the network. Okay, so this kind of things called isolation. That's one of the things you do for containment. Now, make configuration changes. Okay, so you want to do neutralize an attack, limit the spread. We're still talking about that. That how do we do segmentation? Okay, still talking about that. So configuration changes may need to be applied to the following firewall rules and digital certification. Again, containment is going on. Okay, let's talk about this check the knowledge check activity. What must be incorporated into network design to restrict attackers by limiting access to other parts of the network? Segmentation. You want to segment your network. So if one segment is affected, it doesn't go through your entire industry, your entire enterprise. So that will be the D, network segmentation. Okay. Now incident investigation. Now you want to now investigate. Okay, investigate an incident. You want to know whether it is really an incident and how it happened, why it happened, what can be done in the future to prevent it. A thorough investigation, a thorough analysis has to be done. Okay, that's normal. That's like any other incident in the world. Okay, how do you do investigation? You look at the data. Where do you find the data? You have all kind of logs. Okay, every device has log. Every computer, every PC, every laptop, every router, switch, everything, every firewall, every SIM system, okay, every IPS, IDS, every kind of device has some kind of log. You want to analyze the log. Okay, security log, system log. That is one way to, uh, you know, one source of your data. Now, log files continued. Okay. Now, sometimes the log files could be problematic because enormous amount of logs you have from all the devices. So you need to find some methodologies, how to organize, how to manage, how to analyze, how to create reports, how to sort the logs. Okay, there are some automated software for that to do that for you. You know, for example, like the syslog server. Okay, for example, the NX log is a very well-known software. Now, and basically we're talking about right here, I can see the syslog, NXlog, rsyslog, syslog-ng, and journal control. Okay, syslog is basically your Unix-based a system log server where you have a server machine where all the devices are going to send the log into that machine. That's called a syslog. They use the protocol, the system. Okay, NXlog is a platform, is a multi-platform log management software. Okay, R syslog, this is called Rocket Fast Log. That's for Unix. Syslog ng also for Unix system, Linux system. Journal control also for Linux system. Next, let's see. Other data resources. Okay, data can be accumulated. Okay, and also some other sources you can get some data from, like IP monitor. IP monitor is a tool that monitors an IP address. when a domain is connected to that IP, if a new domain is added to that IP, if a domain is removed from that IP. So an IP is always monitored and changes are recorded by the IP monitor software. Metadata is like the data about data, like you have a file, who is the author of the file, that kind of data, some other data related to that data. Analyzers, we know that we can capture some packet and some traffic and analyze it, and of course vulnerability scan. Okay, now talking about digital forensic. Okay, what is digital forensic? Okay, I have to actually call off this video at this time. We are just halfway through and out of time. I think I should leave now. So basically I'll see you on the class. I end this video here today. Thank you.